Okay, so in this video we're going to have a look at the topic of compound interest under financial maths. So for this type of question we have a formula in our log tables. Towards the end, f is equal to p times 1 plus I to the power of t. Now, just in terms of this formula, they tell you in the log tables, but f stands for future value, so what the money will grow to. P is the present value, so what you have now, what you're, say, lodging in the account. Then I is your interest. And the most important thing about this formula is that your interest is written as a decimal, and then t is equal to time. Okay, so always these 4 points, write them out before you start. So if we look at this question, 25,400 was borrowed at 3.5% per annum. So that just means per year. So there's our time period for 10 years. And if we look, the interest rate is charged per year and it's 10 years. It's borrowed first, so that's fine. Calculate the interest. So what we have here is P is 25,400. F we don't know because we don't know what it will grow to with the interest. I as a decimal, 0.035. So you just take 3.5 and divide it by 100, and then t is equal to 10. So we get f is going to equal 25,400 times 1 plus 0.035 to the power of 10. We can tidy that up. And then into our calculator, so we have 25,400, open a bracket, 1.035, close it to the power of 10. F will equal 35,829.20852. Very important in financial maths questions. You'll usually end up with decimals. Avoid rounding until your very last step when you're writing your answer. If you round too early, it can throw off your calculations ever so slightly. Now, just back to the question, we were asked to calculate the interest. So we have the final amount. We know the initial amount. So if we subtract them from each other, we'll end up with the final amount. So for interest, it'll be 35,829.20852 minus 25,400. We get 10,429.20852. And now we can round to 2 decimal places. Okay, so there's our answer for that question. This next one here, found the amount to the nearest cent that needs to be invested at a rate of 5% per annum to give 2,500 in 5 years' time. So we'll write out our formula. Okay, so they tell us it'll grow to 2,500. P we don't know. The interest rate as a decimal, 0.05, and then t is equal to 5 because it's 5 years. So 2,500 will equal p times 1 plus 0.05 to the power of 5. So I'll tidy up this bracket and then divide across by it. So I get 2,500 over 1.05 to the power of 5 equals p. Into your calculator, 2,500 over 1.05 to the power of 5 will give 1958.815416, and we'll just round it to 2 decimal places as we're told nearest cent, so 1958.82. Okay, there's that question. And then this one here, we're told 50,000 is invested in a bank offering an AER, so that's annual equivalent rate of 3.5%. How long will it take this investment to double in value? So we're being asked to solve for t now. So again, we write out our formula. F is equal to p times 1 plus I to the power of t. We know it's invested 50,000, and they tell us that doubles, so then the future value is going to be 100,000. The interest rate is 0.035, and t we don't know. So we get 100,000 equals 50,000 times 1.035 to the power of t. I'll divide across by 50,000. So we'll get 2 is equal to 1.035 to the power of t. I have an unknown power, so that forces me into using logs. So we get log to the base 1.035 of 2 equals t. Enter your calculator. So we get 20.14879168. And we'll go for 2 decimal places. So 20.15 years. And then the quickest way that we can check is treat it as if we're trying to solve for f. So we'd to take p, which is 50,000. So you can just test this on your calculator, times 1.035 to the power of 20.15, and that gives us 100,000 and €4.1569. So we've just gone over the 100,000, so double the investment. So these types of questions, you can always go back and double check your answer. Just sub 3 of the 4 variables in. Usually the easiest one to solve for is f in this case, or to verify is f. Okay, so that's us done for using the compound interest formula.